Energy comes in many different forms. There are two important forms of energy you're going to need to know for Physics 1. Well, aloha everyone. Today we're going to talk about two very important forms of energy. Potential energy is energy that is stored in a system due to either the configuration of the system or interaction with a field. When we talk about potential energy, we're talking about energy that is stored. Usually, when we talk about potential energy, if we don't put a qualifier on it, we're talking about gravitational potential energy, the ability of something to fall. Gravitational potential energy. And in order to calculate the gravitational potential energy, we're going to use the following formula. U, capital U, sub G, is equal to M times G times H. Here, the capital U stands for potential energy. The G shows that it's gravitational. M obviously is for mass. G is the acceleration due to gravity. And H is going to be the height above ground. And when we say height above ground, we're talking about how high is it above whatever level we are calling zero. Now, if you're on the second floor, but you don't think things are going to fall all the way to the first floor, you might as well take the ground of the second floor as your ground. In fact, you can choose where that zero level is going to be. Here's an example of how we would apply this formula. So let's say that we have an object here. Its mass is 10 kilograms. And it is a height of, I don't know, let's make it 5 meters above what we're going to call ground. And the ground is going to be where H is equal to 0 meters. Okay, so we can see we have this object. We are 5 meters above the ground. And how much potential energy does it have in that configuration? So you can imagine this is part of a movie. We paused it, and this is what it looks like right now. Okay, so we can say U sub G equals M times G times H. If you had to have a hard time remembering that formula, just remember Ugh McGuh. All right, so Ugh is equal to 10 kilograms times 9.81 meters per second times an H of 5 meters. This is equal to, I get 490.5 joules. Now, you'll notice I used the unit joules here, because if you look at these units, you'll see it's a kilogram, meter, so it's a meter squared, over second squared, which is the same as saying a newton times a meter, because a kilogram meter per second would be a newton, and a newton times a meter is a joule. So yes, our units for energy are just the same as the units for work. That means energy is measured in joules. There are other forms of potential energy, most notably elastic potential energy, but there's also electrostatic potential energy, there's magnetic potential energy, there's a lot of different forms of potential energy. But for now, we're going to stick with gravitational potential energy for the most of it. Later on in the course, we'll talk about elastic potential energy, and then as time goes on, we will, in Physics 2, we'll talk about things like electrostatic potential energy. Most of the time, when we talk about potential energy, we're talking about the ability of an object to fall. and move around once it hits the ground. But there's other forms of potential energy. I can give this object more energy by flipping it inside out. That gives it what we call elastic potential energy. Then, when I drop this, it pops up quite a bit higher because it had elastic potential energy now. Kinetic energy is the energy of motion. When we talk about kinetic energy is the energy of motion. Kinetic energy has to do with motion. So, could an object have both gravitational potential energy and kinetic energy at the same time? Yes, absolutely. If it has a height above the ground, it has gravitational potential energy. If it's moving, it has kinetic energy. So an airplane, for instance, would have both. It's moving through the air as it's flying, and it is also way up in the sky, which means it has a height above the ground. So kinetic energy is about motion. And the formula for kinetic energy, we are going to use the letter K, capital K, is equal to 1/2 mv squared. K obviously stands for kinetic energy. M is going to be the mass, and V is going to be the velocity. Or I guess speed, because we don't really worry about the vector because it gets squared out anyway. All right, so kinetic energy is 1/2 mv squared. Let's see an example of this. Let's imagine we have a dude on a bicycle here. So here we go. Oh, and always wear your helmet. There we go. All right, so here's our guy on a bicycle, and maybe the mass of this entire system, him, the bicycle, everything, his helmet, is going to be, let's make it 100 kilograms. And let's make him move this way with a speed of, I don't know, how about 5 meters per second. And I want to know, what is his kinetic energy? Well, K is going to be equal to 1/2 mv squared. So in this case, we are going to use K is equal to 1/2 times a mass of 100 kilograms times a speed of 5 meters per second squared. Let's see, 5 squared is 25. 25 times 100 is 2,500, and half of that is 1,250? Yeah, 1,250. You'll notice kilogram, meter squared over second squared again, which is a joule. So both potential energy and kinetic energy, and just about every other form of energy you can think of, is going to be measured in joules. So this answer, 1,250 joules. So that's really all there is to it for potential energy, at least gravitational potential energy, and kinetic energy. Oh, one more thing. By the way, you might see sometimes people write it as this: potential energy and kinetic energy. That's okay if you understand what they're talking about, but sometimes this looks like a P times an E and a K times an E, which can confuse people. So that's why in this class we will be using just K, and not a PE, we will be using U. Why not P? Because P was already taken for power. Well, yeah, that's all there is to it about kinetic energy and potential energy. So, mahalo for watching, and see you next time.